Okay, so good morning everyone. So today we're going to discuss trigonometric functions. Okay, so first we're going to discuss trigonometric ratios. So our study of trigonometry begins with studying the right triangle and considering that we have a right triangle, so therefore we're also going to consider the angles. So acute angles are angles that are measured that is less than 90 degrees and greater than 0 degrees. Okay, so to represent the angle we are going to use a different Greek letters. We have the alpha, the beta, gamma, and theta, or also we have this phi. So these are the most commonly used Greek letters to represent the angle of the triangle. Okay, now if you're going to consider a right triangle, so say for example you're going to consider the figure below. So we have here a triangle, okay, and the angle now is represented by this one theta. Okay, so if we are going to look at the different sides of a triangle, so we have the opposite. Okay, that is the opposite of your angle. We have the adjacent that means beside your angle, and we have the hypotenuse. So the hypotenuse is the longest length or side of your triangle. Okay, so this is very useful for us to derive with the different trigonometric ratios. Okay, so trigonometric ratios, the lengths of the sides of the triangle, are used to define the six trigonometric ratios. So what are the six trigonometric ratios? So we have the sine, cosine, tangent, cosecant, secant, and cotangent. Okay, so take note that your cosecant is the inverse of your sine, and your cosecant or secant rather is the inverse of what? Cosine, and cotangent is the inverse of what? Tangent. Okay, so when you're going to inverse the sine, that will give you cosecant. If you're going to inverse the cosine, that will give you secant. And if you're going to inverse the tangent, then that will give you cotangent. Okay, so these are the six trigonometric ratios. So the sine of theta is the length of the opposite divided by the length of the hypotenuse. So therefore, this sine theta here, okay, we're going to look at the figure. So the sine theta, okay, the one that is being highlighted here, okay, it represents that sine is equals to your opposite over the hypotenuse. That is why we have this what we call the saw, that means opposite over hypotenuse, ka, that means adjacent over hypotenuse, and towa, that means opposite over adjacent. And for cosecant, you have the what? Okay, we have the cow that means cotangent, and that is adjacent over opposite. Because take note that if you're going to reverse this one, okay, the towa, if you're going to reverse this one, that will become adjacent over opposite. That is cotangent already. And then we have the um, sha. Okay, sha that means s that means secant, and h represents hypotenuse over adjacent. Okay, and we have the cho. Okay, cho represents cosecant, and h represents hypotenuse over opposite. So in order for you to memorize the different trigonometric ratios, just say it: so, ka, towa, kau, sha, cho. Okay, so, ka, towa, kau, sha, cho. So in order for you to easily memorize the different trigonometric ratios with their corresponding sides. Okay, so next, so again the ratio depends on the angle. Okay, it depends on the angle, and thus the function of theta. So the notation of sine theta actually means that that is sine theta. So where sine is the same of the function, so cosine also the same thing. it is adjacent over hypotenuse. We call that one as, diba, kanina you have the ka. Ka means cosine, and then adjacent over hypotenuse. Okay, so these are now the six trigonometric ratios based on the given acute angle, which is represented by theta here. So this is based on theta. Okay, now if you're going to have beta here on the other angle, so that's another story. Okay, so we have here sine theta. So sine theta, you have the opposite of hypotenuse, again adjacent, hypotenuse, the same thing, no? All you have to do is just to memorize the um, um, so katowa, and then you have the cow shacho. Okay, whatever is the reference angle, so that's the same ratio that you're going to do or to memorize. Okay, now example number one. So the right triangle shown at the left, so we're going to find now the what six trigonometric functions of your theta and your alpha. Okay, so here first we have the sine theta. So this angle here, okay? So theta is opposite over hypotenuse. So the opposite of your theta here is 12. Okay, this is the opposite. This is the hypotenuse of your theta, and this is what we call the adjacent of your theta. Okay, so therefore if you're going to find now the six trigonometric functions of your sine theta, or your theta rather, opposite is 12, that's correct, and then hypotenuse is 13. Cosine, you have the adjacent is 5, that's correct, and then the hypotenuse is 13. And then we have also, okay, tan theta, so the opposite is 12 and the adjacent is 5. Okay, cosecant, hypotenuse 13, opposite is 12. Second, you have hypotenuse 13, adjacent is 5. Cotangent, that is adjacent 5, and then opposite, that is 12. Okay, and now for the alpha, as I've said, alpha now it depends on where the angle is, so therefore your alpha is here. So what is now the opposite side of your alpha? So the opposite side of your alpha is this one, 5. This will be the opposite of your alpha. Again, the hypotenuse remains the same, and your 12 will become what? Your 12 will become adjacent. So this will become adjacent in terms of alpha. Okay, so when you're going to get now the six trigonometric functions of your alpha, the opposite of your alpha is of course 5. Okay, this one, and then the hypotenuse is 13, and then cosecant, okay, the adjacent now of your alpha is 12, and then of course the hypotenuse is 13. Okay, for tangent, opposite, that is 5, and the adjacent is 12. So the same thing with cosecant, hypotenuse is 13, opposite is 5. Okay, second, hypotenuse is 13, adjacent is 12, that's correct. And then cotangent, you have the adjacent, that is 12, and then the opposite is 5. Okay, so these are now the six different trigonometric functions of your alpha and your theta. Okay, now the reciprocals functions, as I've said a while ago, that your cosecant is the inverse of your sine, and your secant is the inverse of your cosine, and your cotangent is the inverse of your tangent. Okay, so given that the sine or sine phi, okay, is equals to 4 over 5, okay, and the cosine of phi is 3 over 4, and the tangent of phi is 4 over 3. Find the cosecant, secant, and cotangent. Okay, now it's very simple, simply because your this one, for example, your sine, okay, your sine is what? Your sine is 1 over, I mean your sine is equivalent, or your cosecant is 1 over sine theta. So what is now your sine, I mean sine phi? So what is now your sine phi? Your sine phi is 4 over 5. Okay, So what you're going to do is just to reciprocate this one, the values. Okay, reciprocate. So what you're going to have is this value. Okay, this one. And also for your second, your second is the inverse of cosine, so 1 over sine. And then you have 1 over the value of your cosine is 3 over 5, so just reverse this one. Okay, so therefore the answer will be 5 over 3. Okay, so this is just like 1 over 1. So you multiply this one, you multiply this one. So that becomes 5 over 3. The same thing with your cotangent. Your cotangent is what? 1 over tangent. And the value of your tangent phi is 4 over 3. So therefore, 1 over 4 over 3, that will be equivalent to 3 over 4. So the values now of your cosecant is 5 over 4. Your second now is 5 over 3. And your cotangent now is 3 over 4. Okay? Now, if you're going to draw a diagram here, a triangle, let us try to check. Obviously, in our diagram, okay, the highest length or the highest value is the hypotenuse. So obviously, this is the hypotenuse. If this is your phi here, okay, your phi, now if you're going to look at your sine, so sine is opposite over hypotenuse. So that means if this is your phi here, therefore your opposite here is 4 and your hypotenuse is 5. Here, cosine, your cosine is adjacent over hypotenuse, so that means that adjacent of phi is here, that is 3. Okay, so therefore this will be your values of the triangle. So you have 3, 4, 5 if your phi is here, located here in this angle. Now on the other side, okay, so say for example your triangle, okay, this is your triangle, okay, okay, so say for example your phi is here, okay, obviously this is the hypotenuse, okay, that is what, 5, and then opposite of your hypotenuse is 4, this is 4, and this one is 3, that is the adjacent. Okay, so you have two figures here depending on where the angle of your phi is located. Okay, so triangles are said to be similar if the corresponding angles have the same measurement. Okay, they're just what we call the similarity of the triangle. So if you're going to look at this angle, though this angle is smaller compared to this angle, but they are just similar in terms of what? In terms of angle. Okay, they're just similar. So here, say for example here, so say for example alpha, sine of alpha. Alpha is what? Opposite over hypotenuse. In the smaller triangle, the opposite of your alpha is 4 over 5. Okay? Now, in the big triangle, you have the sine alpha of a larger triangle opposite of your hypotenuse. So, opposite of your alpha is 16, hypotenuse is what? 20. What you're going to do is you can reduce this one. So, divided by 4, what? That will give you what? 4 over 5. So, the same. Okay? The same. And if you're going to convert that one to angle, they have the same angle. Okay, so that is the similarity of triangles. Okay, so here we're going to observe the sine, cosine, and tangent values of your beta in each triangle. Okay, so first triangle, you have sine beta, you have 3 over 5. Okay, this one in the similarity. Okay, as what I have explained this a while ago, this one. Okay, they're just similar. So sine beta, so this one is using sine beta. Okay, so okay, they're just similar. Now next is the sixth functions, okay, related to trigonometric ratios. Okay, so say for example we're going to find other trigonometric functions of your triangle. Okay, so in the given example, beta is equivalent to, okay, your angle here Okay, your angle beta here, in which the given values is what? 6 over 7, and beta is an acute angle. So find the other 5 trigonometric functions. So how are you going to do this one? So first, beta. Okay, so beta, your angle here, your angle is here, and 6 is what? Opposite of your beta, and of course 7 is the hypotenuse. Okay, so first we have to identify this one: opposite over hypotenuse. Okay, so that will what? Fall sa sine beta. Sine beta is equals to opposite over hypotenuse. Okay, now what we're going to do is we're going to identify also what is the value of your a here, or the adjacent. Okay, we're going to identify the value of your adjacent in order for us to find the 6 trigonometric functions. So to do that one, what we're going to do is we're going to find the value of your adjacent by what? By Pythagorean theorem. Okay, Pythagorean theorem. So Pythagorean theorem states that c squared is equals to a squared plus b squared. Now c is the hypotenuse, and a or b could be the adjacent or the opposite side. Okay, so since given is the hypotenuse, and say for example your b is your adjacent, okay, or a, could be your adjacent. In this example, he is using a as your adjacent, and well, we can find now the value of your a squared. Okay, so what is your c, or the hypotenuse? So the hypotenuse is 7 squared, and that is equal to your a squared plus what is the value of your b, or the opposite side? That is 6 squared. Okay, so therefore if we're going to transpose that one, um, it will give us what? A squared is equals to, you have 49, okay, minus 6 times 6, that is 36, or that will give us what? That will give us 13. So therefore your adjacent is equivalent to square root of 13. Okay, so here we're going to use Pythagorean theorem to identify the other side of your triangle. So in this case, we have now what? The value of your adjacent, which is equivalent to what? Square root of 13. So we have now all the values of your triangle. So in this case, we can now identify the 6 trigonometric functions. Okay, so these are now the 6 trigonometric functions of your triangle. So here in the triangle, where beta is your angle, and your hypotenuse is 7, and your opposite is what? 6, and your adjacent is square root of 13. So we have here the sine opposite, that is 6 over 7. You have cosine, that is adjacent over hypotenuse, square root of 13 over 7. Then we have also tangent. Tangent is 6 over square root of 13. Okay, now in this case, we're going to remove the radical here in your denominator. That is why it becomes 6 over square root of 13 over 13. So what we did here is that we just have this one, square root of 13. In order for you to remove the radical, remember what we had last time? We're just going to multiply that one by square root of 13 over square root of 13. So in order for us to remove the radical, so what will happen here? It will become 6 square root of 13 over 13. Okay, so next, the cosecant. Okay, cosecant, so it's just the inverse of sine, that will become 7 over 6. And then you have the secant, the inverse of cosine. Again, you have a radical here, so what we're going to do, we're going to remove the radical. Okay, we're going to remove the radical, so it becomes what? 7 square root of 13 over 13. And of course, for the cotangent inverse, in which it is the inverse of the tangent, so therefore you have the square root of 13 over 6. So these are now the 6 trigonometric functions of your triangle, where a, or the adjacent here, is unknown. So we find the missing value first before we identify the 6 trigonometric functions. Okay, so these are now the functions of 30, 40, and 60. 35, 45, and 60 degrees. Okay, so if a triangle is a right triangle, okay, especially for, okay, where angle is having a exact, uh, I mean, um exact angle, like for example here, this one is 90 degrees, and this one, if this is 45 degrees, obviously this one is also 45 degrees, because as I've said, the total value of your um, triangle is equivalent to 180. So this is 90 already. Okay, you're going to add the 245, that will give you what, 90. So 90 plus 90, that will give you what, 180. Okay, this is for 45, and then for 30 and 60. So if you have this angle, okay, for example this one, wherein you have 45 90 degrees here, okay, if this will be 60 degrees, so this will be what, 30 degrees. Okay, or this will be 30 degrees, this will be what, 60 degrees. That is the 60 um 30 degrees rule. Okay, so again, if you're going to add all the um, angles, that will be equivalent to 180. So in the Pythagorean theorem below, it follows here that your c squared is equals to square root of 2 if you have a triangle. Like for example here, a triangle, the opposite is 1 and the adjacent is 1. For example, this is theta. Okay, if your opposite and your adjacent is 1, so therefore your hypotenuse is equivalent to square root of 2. Okay, so later on you will know that one. Okay, so as I've said, if you have a 45 angle degree, so most probably that your lengths are equal. So the adjacent and the opposite, okay, are equal. That means you're having a 1 by 1 um, side or length of your triangle, and therefore your hypotenuse will be square root of 2. So here, okay, what you're going to do is, okay, sine of 45, that is equivalent to what, 0.701, 0.7071. Okay, so the same thing with cosine, that is 0.701, and for tangent 45, that is equivalent to 1. Okay, so these are the different values now of what, of your angles. If you're going to press in your calculator sine 45 degrees, so this will be the result. Also cosine, this will be the result. And for tangent 45, this will be the result. Okay, or just simply divide this one, 1 divided by square root of 2, okay, or 2 square root of square root of 2 over 2, so the result is this one, really 0.7071. Okay, so again, for the 60 and 30 degrees, usually that is derived from what, equilateral triangle. So equilateral triangle, so the angle here is what, 60 degrees, this one is also 60 degrees, and this one is also 60 degrees, so that will still give you what, 180 degrees, okay, in total. So if you are going to divide an equilateral triangle, of course, since they are all equal angles, so both angles here are 60, and of course the total angle here is 60. If you are going to cut it in the middle, that will give you a right triangle. So therefore, what will happen here, the other side of their angle will become 30 degrees. This one is also become 30 degrees. Okay, because you're going to divide it into half the 60 degrees in order for you to get a what, a equilateral or a right triangle rather. So if that will be the case, no, equilateral triangle having the sides of 2 2, and okay, we have here 2, and then we have here 1. Okay, since they're all the same sides, so that means that the total length here is equivalent to what? 2. And the total length here is 2, the total length here is 2. If we're going to divide it in the middle, so therefore the 2 will be divided into what? 1 by 1. So therefore your sides here will become 1 and your hypotenuse here will become 2. So what we're going to do, we're going to find the opposite of your 60 degrees. Okay? Or it could be the adjacent of what? Adjacent of 30 degrees. So to find that one, again, we're going to use Pythagorean theorem. Again, your C is the hypotenuse, in which this is the hypotenuse. Okay? Now, one of your sides, say for example, it could be the opposite side or the adjacent side is equivalent to 1. So we're going to identify now this side. Okay? So in that case, we have now, okay, plus 1 is equals to 4. Then, of course, 4 minus 1 that is equivalent to 3. Or a is equivalent to square root of 3. So that is now the value of the other side, square root of 3. Okay, so based on the values, we are already able to determine the values of the other side, the unknown side. So therefore, if we are going to look at the trigonometric function of 30 degrees and 60 degrees, so we have these values. So take note that the opposite of 30 degrees is 1, the adjacent is square root of 3. So therefore, if we are going to consider this one of the angle that is equivalent to 30 degrees, the opposite is 1, the hypotenuse is 2, adjacent is square root of 3, hypotenuse is 2, of course, opposite is 1, and then we have the adjacent of square root of 3. In for considering the 60 degrees angle, okay, of course, if you're going to look at this one, the 60 degrees angle, the opposite is what? A, which is square root of 3, and the adjacent is 1, and the hypotenuse is equals to 2. So therefore here, sine, the opposite is square root of 3, hypotenuse is 2, okay, cosine, that is 1, and then also we have this 2 as your hypotenuse, okay, tangent, that is opposite is square root of 3, and then 1 is your adjacent. Okay, so these are now the different values of your functions of your 30 degrees and 60 degrees. So if you're going to look at this table, so you'll be able to identify now here that the sine of 30 degrees is 1/2. In terms of 45 degrees, square root of 2 over 2. And in terms of 60 degrees, that is square root of 3 over 2. Okay, so later on you will be, it's important also to memorize this one, because this will really help you when you're going to solve problems later on. Okay, especially in terms of what? Okay, so 45 degrees, 30 degrees angle, and 60 degrees angle. If these are the given angles, so most probably this will be the values that you will be getting. Okay, so better to memorize that one. But the most important thing is that you know the concept of what will be the opposite side, the adjacent, and the hypotenuse. Okay, now it depends on the reference angle. Okay, now example number 4. So we're going now to find the height of a hot air balloon. So as a hot air balloon began to rise, so the ground crew drove 1.2 miles to an observation station. Okay, now the initial observation from the station estimated the angle between the ground and the line of sight to the balloon to be 30 degrees. So approximately how high was the balloon at that point? Okay, so we just assume that the wind velocity is low and the balloon rose vertically for the first few minutes. Okay, so what we're going to identify is the height of the balloon from the ground, this one. Okay, how high is the balloon already? Okay, so we try to do a triangle here. Okay, now take note that the line of sight, okay, that the line of sight, the angle of the line of sight is what? The angle of elevation. Okay, this is the angle of elevation. of the line of sight is 30 degrees. Okay, so we have given here the different values, like for example sine of 30 degrees, and that is what the distance from the ground of the balloon, okay, to the car is 1.2 miles. Okay, and then we have what we have um, we are going to determine the height of the balloon. Okay, so how are you going to do this? Okay, we have already the diagram. So we have already here a triangle diagram. We have already the angle. We have already as a initial distance. We have also to determine the height. Okay, so obviously, okay, what we're going to do here is what we're going to determine the opposite, and then we have the what adjacent. So opposite, adjacent, so what we're going to do is we're going to use the function what tangent. Okay, tangent is opposite over adjacent, that is SOHCAHTOA. Okay, so here is the solution. So we have tangent here, so the angle is 30 degrees, and then opposite and adjacent. So the opposite is the height, which is the unknown. Okay, and we have the 1.2 miles distance. So just cross multiply, so that will be 1.2 tangent of 30 degrees, or is equals to what the height. Now what is now the 30 degrees function? Actually you can do it um, by just pressing your calculator. So you can have 30 degrees or 1.2. Okay, so you can type in your calculator 1.2, okay, times tangent of 30 degrees. Okay, so that will give you what, if you're going to use your calculator, okay, this will give you what, that is 0.6928. Okay, say for example mga 5 decimal places, so that will give you 0.6928. That's the value. Now as I've said, it would be easier for you if you're going to use the table that we had for the functions of 30 degrees, 60 degrees, and 45 degrees. Okay, so if we're going to look at here in the table, remember in the table, so your tan 30 degrees equivalent to what, square root of 3 over 3. So we use that value here. Okay, this one, we use that value so that it would be easier for us to do the multiplication. Okay, if you don't have any scientific calculator, you cannot uh, do the tangent 30 or compute for the tangent 30, but here we can just simply multiply 1.2 times the square root of 3. Okay, and then that will be divided by 3. Okay, so this result is just the same. The result is here, this one, whether you're going to use the tan 30 or we're going to use this value, because they're just the same, it will give you this value, and then this one is being rounded off, that is why it becomes what, 0.7. Okay, so meaning that the height of the balloon is approximately 0.7 miles. Okay, or if you're going to convert that into feet, that is about 3,692 feet. Okay, so that is now the height of the balloon. Okay, so what you're going to do, you're going to do these exercises. What you're going to do is you're going to find the 6 trigonometric functions of the specified angle. So here you're going to find the 6 trigonometric functions of alpha, the 6 trigonometric functions of phi, and the 6 trigonometric functions of theta. Okay, so that is what you're going to answer. So more or less there are only 18 values here. So 6 for A, 6 for B, and 6 for C. So only those specified angles. And another thing, you're going to answer this one. So you're going to find the distance across the river. So there is already a diagram that is being shown below. You just follow the diagram. you're going to find the distance of your B going to your C. Okay? And then another one is you're going to find the distance between the bases. Okay, from first base to the third base. So what is the distance now of the first base going to the third base? Okay. Okay, thank you everyone for your time and for listening. God bless you all. By the way, I will just be posting in the LMS all the assignment for you to submit your exercises that is presented here in the video. Okay? Thank you everyone. God bless.